Lovely people, welcome back once again to my channel. Today we are going to look at exponents and how we can simplify exponential expressions. Here we are not just solving for the unknown variable, but we are going to simplify complex exponential expressions and reduce it to the simplest form. Now look at this. This is simplify the following. We are given 2 exponent x plus 2 plus 5 times exponents 2 exponent x plus 2 exponent x divided by 5 times 2 exponent x. Now we have a problem here. We cannot easily apply the laws of exponents here because the laws of exponents has to do with multiplication and division. Here we have addition and subtraction. Please note, whenever you have division or addition and subtraction, separating exponents, think factorization, because that's the only way to solve that. Think factorization, check if there's a common factor. After factorizing whatever that is left, see if they can actually cancel out. That is the only approach here. So let's look at this. Remember, if you have exponent of the same base, but different exponent be multiplied, you add the exponent. So what we do here is we ask ourselves, where did this come from? So that we can take it back to that place. So this came from 2 exponent x times 2 exponent 2. Then we, remember, if you do this, you get back. So we, in this case, we went backwards. We take it back to where we got it from. And then we go on and divide with 5 times exponent to 2 exponent x. Now we have a common factor in the form of 2 exponent x here, 2 exponent x here, in every section after the plus sign. So we take out our common factor. So in this case, our common factor is 2 exponent x. Into the first section, we have 2 squared, which is 4, plus 2 exponent x. Divide this section with the common factor, we have 5 left here. If we divide the common factor with this last, anything dividing itself gives you a 1. Please, this is a common mistake. You don't just omit this. Remember, it is a section of its own. Dividing with the common factor gives you a 1. Divided by 5 times 2 exponent x, which is the denominator. Now we can go on. This, because this multiplication can cancel out this. And then for the numerator, we have 4 plus 5, 9, plus 1 is equals to 10. And the denominator is 5. So our final answer is 2, simplified. So we can use exponents to simplify complex expressions of this form by applying factorization. Let's look at the second question. Second question, you have 9 exponent x minus 1 multiplying 24 exponent x plus 1 divided by 27 exponent x multiplying 8 exponent x. When we have this type of problem, remember multiplication deals with the same base. If we cannot reduce this to the same base, we think of the combinations that can work. But the approach to this is to reduce everything in that expression to the lowest possible base. Reduce everything to the lowest possible base. All of them. All of them must be reduced to the lowest possible base. So let's look at this. So the first one, I can reduce it to 3 all squared into x minus 1 times. Now 24 can be broken down into 2 and 3 because we cannot get a common base to reduce that to. So if we have 2 to the power of 8 times, okay, let's say 8 times 4. 8 times 3 gives us 24. 8 times 4 is actually 32. 8 times 3 gives us 24. And 8 is actually 2 to the power of 3 times 3. 8 times 3 gives us 24, all to the power of x plus 1. Now, because I'm working with the base of 2 and 3, I will stick to that. Here, 27 is 3 to the power of 3. remember the foundation of exponents is always to reduce them to the lowest possible base. And then times 2 to the power of 3, that's 8. We have 2 to the power of 3, exponent x. Now let's split this. Because we have the basis of 2 and 3, we will allocate each one to its own brother. So here, let's simplify. Remember, this 2 belongs to everything here. So I have 3 to the power of 2x minus 2 times this belongs, the exponent here belongs to both this and this. So I have 2 exponents. 3 times x is 3x. 3 times 1 is 3. Times 3 exponents x plus 1, because it belongs to all of them, which came out from the 24. Now, divided by, this is 3 exponent 3x times 2 exponent 3x. Now let's go forward. If we want to simplify this further, we now group like this and this. So I will have 3 exponents, because multiplication says add the exponent. So I will have 2x minus 2 plus, please put this bracket, it's very important, plus 1 for the numerator, times, I still have 2 exponents, 3x plus 3, divided by, now 3 exponent 3x times 2 exponent 3x. Now let's see what we have. This gives me 2x plus this. So going the next step, I have 3 exponents 2x plus x is 3x. Then minus 2 plus 1 is minus 1. I have simplified the basis of 3 for the numerator. Times 2 exponent 3x plus 3. All over 3 exponent 3x times 2 exponent 3x. Now, going the final up, now we can apply the laws of division of exponents. It says when you are dividing, subtract the exponents. So here, I will take a common exponent, it's common base, and then subtract the exponents. I have 3x minus 1 minus 3x. Into 2 into 3x plus 3 minus 3x also. And then, if I want to take this finally, this will give me, simplified version of that will be 3x minus 3x gone. I'll have 3 to the power of negative 1 for the 3's. For the 2's, I have 3x minus 3x gone. I'll have 2 to the power of 3. So this will give me, remember this is 1 over 3, so I have 1 over 3 times 8. And then my final answer will be 8 over 3. You see the complex expression being reduced using exponents. If you do it properly, in most cases, it gives you a number. I didn't say in all cases, in most cases. You see, we are able to eliminate all the variables using proper exponential simplification, and this is what we have as our answer. Please go through this. If you have any question, please ask. If you have any specific question you also want me to solve, do not hesitate to ask. Continue to share and subscribe to my channel. Have a blessed day.